Out there in the vast expanse of the cosmos, amidst the swirling galaxies and twinkling stars, lurk objects of immense power and mystery, black holes. Imagine a place where gravity is so strong, so overpowering that nothing, not even light, can escape its clutches. That, my friends, is a black hole, a cosmic abyss that has captivated the imaginations of scientists and stargazers alike for decades. Black holes are not empty spaces, as their name might suggest. Instead, they are regions of space-time where an incredible amount of matter is crammed into an incredibly small volume. Picture the Earth squeezed into a marble or the Sun compressed into a city. That's the kind of density we're talking about. This extreme density creates a gravitational pull so strong that it warps the fabric of space-time itself, like a bowling ball placed on a trampoline. Anything that ventures too close to this cosmic trapdoor, whether it's a planet, a star, or even light itself, is doomed to be drawn in, never to return. The existence of black holes was first predicted by Albert Einstein's theory of general relativity, a revolutionary idea that reshaped our understanding of gravity. While we can't see black holes directly, their presence is revealed by the effects they have on their surroundings. Not all stars are destined to fade away quietly into the cosmic night. Some, particularly those much more massive than our own sun, meet a far more dramatic and violent end, collapsing in on themselves to form black holes. This process of stellar death and rebirth is one of the most awe-inspiring spectacles in the universe. It all begins when a massive star, having exhausted its nuclear fuel, can no longer support its own weight. The outward pressure from nuclear fusion, which once held the star in balance, dwindles and gravity takes over. The star's core collapses inward, imploding at an astonishing speed. This implosion sends shockwaves rippling through the star's outer layers, blasting them off into space in a brilliant supernova explosion. These explosions are among the most energetic events in the cosmos, briefly outshining entire galaxies. What's left behind after this cosmic cataclysm is the star's core, now compressed to an infinitesimal point of infinite density known as a singularity. This singularity, shrouded by an invisible boundary called the event horizon, is what we know as a black hole. Imagine a boundary in space, a point of no return. Cross this boundary, and you're trapped forever, doomed to be drawn inexorably towards the singularity at the heart of the black hole. This boundary, my friends, is the event horizon, the defining feature of a black hole. The event horizon is not a physical barrier like the surface of a planet or a star. Instead, it's a region of space-time where gravity is so strong that nothing, not even light, can escape its pull. Once something crosses the event horizon, it's as if it's fallen off the edge of the universe. Think of it like this. Imagine you're standing on a moving walkway like those found in airports. The walkway represents space-time and you're walking towards the event horizon. As you get closer to the event horizon, the walkway speeds up. At first you can still walk back against the flow away from the event horizon, but as you get closer the walkway moves faster and faster. Eventually, you reach a point where no matter how fast you walk, you can't outrun the walkway. You're trapped. That's the event horizon. What would happen if you were to fall into a black hole? It's a question that has sparked countless science fiction stories and inspired the imaginations of physicists and dreamers alike. The answer, as it turns out, is both fascinating and terrifying. As you approach the black hole, you'd experience the strange effects of gravity at their most extreme. The immense gravitational pull would stretch your body out like spaghetti, a process scientists aptly call spaghettification. Your feet, closer to the black hole, would experience a much stronger gravitational pull than your head, stretching you out into a long, thin strand. But it's not just your body that would be distorted. Time itself would behave strangely as you neared the event horizon. Time slows down in strong gravitational fields, a phenomenon known as time dilation. To an outside observer watching you fall into the black hole, you would appear to slow down as you approach the event horizon, your image eventually freezing in time. You, however, wouldn't notice anything unusual about time. From your perspective, time would continue to flow normally as you plunged past the event horizon and into the abyss. What would await you on the other side? That, my friends, is a mystery that continues to baffle even the brightest minds in science. Section 5, the singularity, where physics takes a backseat. At the heart of every black hole lies a point of infinite density and zero volume. A place where the laws of physics as we know them break down, the singularity. This enigmatic point, hidden from view by the event horizon, is both the most intriguing and the most perplexing aspect of a black hole. Imagine all the matter that ever fell into the black hole, crushed and compressed into an infinitely small point. That's the singularity, a place where our current understanding of gravity and quantum mechanics can't fully explain what's going on. Some theories suggest that the singularity might be a point where space-time itself comes to an end, a cosmic dead end. Others propose that it could be a gateway to other universes or dimensions, a concept that has fueled countless science fiction stories. The truth is, we simply don't know what happens at the singularity. It's a realm where our current laws of physics break down, and new yet to be discovered principles might govern the very fabric of reality. Section 6. Peering into the abyss, unraveling the mysteries within. Despite the challenges, scientists are constantly striving to unravel the mysteries hidden within these cosmic abysses. While we can't observe the singularity directly, we can study the effects of black holes on their surroundings, providing us with clues about their nature. One way we study black holes is by observing the behavior of matter as it falls into them. As gas and dust spiral towards a black hole, they heat up to incredible temperatures, emitting intense X-rays that we can detect here on Earth. Another way we learn about black holes is by studying the orbits of stars around them. By observing how stars move in the vicinity of a black hole, we can calculate the black hole's mass and spin, providing us with insights into its properties. The Event Horizon Telescope, a global network of telescopes, has even captured the first ever image of a black hole's shadow, providing us with direct visual evidence of these enigmatic objects. This groundbreaking achievement has opened up new avenues for studying black holes and their role in the universe. Section 7. Cosmic Architects. The significance of black holes. Black holes, once considered mere theoretical curiosities, are now recognized as fundamental constituents of the cosmos, playing a crucial role in the evolution of galaxies and the universe as a whole. Their influence extends far beyond their immediate surroundings, shaping the cosmic landscape on grand scales. Supermassive black holes, millions or even billions of times the mass of our Sun, are believed to reside at the centers of most galaxies, including our own Milky Way. These gravitational behemoths act as cosmic anchors, influencing the formation and evolution of their host galaxies. Black holes also play a vital role in the creation of heavy elements. The intense energy released during the formation of black holes and the collisions between them can forge heavy elements like gold, platinum, and uranium, seeding the universe with the building blocks of planets and life itself. By studying black holes, we gain a deeper understanding of gravity, the fundamental force that shapes the universe. These cosmic laboratories provide us with a unique opportunity to test our current theories of physics and explore the limits of our knowledge. Section 8. The universe's greatest enigma awaits. Black holes remain one of the most captivating and enigmatic objects in the cosmos, a testament to the boundless wonders of the universe. They are cosmic abysses where the known laws of physics break down, and new yet to be discovered principles might govern the very fabric of space-time. As we continue to explore the universe and unravel the mysteries of black holes, we are constantly reminded of the vastness of our ignorance and the boundless potential for discovery that lies ahead. The quest to understand black holes is a journey into the unknown, a pursuit of knowledge that will undoubtedly lead to new and revolutionary insights into the nature of the universe and our place within it. To delve deeper into the cosmos and explore more mind-blowing phenomena, be sure to subscribe to our channel for more captivating content. The universe is full of wonders waiting to be discovered.